In this video, we're going to talk about relations. A relation is when elements in one set are associated or related to elements in a second set. So one way to show a relation is writing the two sets as a set of ordered pairs. So for an example, this 2 in the first set maps to -4 in the second set. -3 maps to 7, and 2 maps to 5. So the domain is a set of all inputs in the relation. Well, in a set of ordered pairs, the x-coordinates are the domain, or referred to as the independent variable. The range is a set of all outputs in the relation. As a set of ordered pairs, the y-coordinates is the range, or what is called the dependent variable. So let's write the domain and range of relation A. Well, the domain, we want to write smallest to largest is -3 and 2. I only need to write 2 once for the domain. And because it's individual values, we use braces. For the range, the y-coordinates, well, smallest to largest, that's -4, 5, and 7. Because they're individual y-coordinates, we use braces. Okay, so relations can also be expressed with mappings, a graph, or a table. This is an example of a mapping. Miranda is being mapped to 5. So you can always follow what's being mapped to when you follow the arrows. So the domain in this particular mapping are the names. And the range are the numbers. Okay, let's take a look at the next example. Again, we're dealing with a set of ordered pairs. So here I would suggest writing it as a relation. So let's call it B. So this ordered pair is -1, -4. This ordered pair is 0, 0. This ordered pair is 1, 3. And this ordered pair is 5, 0. So then the domain, or the x-coordinates, would be -1, 0, 1, and 5. The range would be the y-coordinates would be -4, 0. Again, only have to write once, and 3. Okay, let's take a look at the next example then. We are now actually have a picture that is connected. Okay? Remember, the domain is all the x values. Okay? Well, no matter what, I can always find a particular x-coordinate on this line somewhere because of the arrow going forever to the left here and forever to the right here. This is an interval of x values that are somewhere on the line. Okay? So we will be using interval notation for this. So from the far left, that's -infinity, to the far right, that is +infinity. Okay, let's take a look at the range. Now that's the y values. Okay? So again, no matter what particular y value that I am interested in, I can find this somewhere on this line because this arrow goes forever up and this arrow goes forever down. So we start from the bottom and work our way up because smallest to largest. So here, the range is also -infinity to +infinity. Okay, let's take a look at the next example then. We're dealing with a circle here, so let's start with the domain. Here it does not go on forever. In fact, this is as far to the left as this goes, so that is -3. Because that's a closed circle, I will put a bracket and not a parenthesis. But every other value, x value in the domain, I can find somewhere on this graph until I get to +3. This is a closed circle, so it'll be a bracket afterwards. All right, let's talk about the range then. So again, we're looking at possible y values. The smallest y value can be found here, which is -3. every other y value can be found somewhere in this circle all the way up to positive 3. And again, because it's a closed circle, that will be a bracket there. Okay, let's take a look at the next example. Starting with the domain. Again, because these arrows are going forever to the left and forever to the right, I can find every single x value somewhere on this parabola. Okay? It is an interval of solutions, so it's from negative infinity to positive infinity. Now, the range is a different story. These arrows represent that they also go down. So we know we can find range values somewhere on the parabola. So we know it's going to start at negative infinity, but it does not go up forever. In fact, the highest range value for this is right here at 3. And again, because it is a closed point there, or a closed circle, it'll be a bracket afterwards. Okay, one other example I want to take a look at. When you have a relation that has open circles, this changes a little bit with the domain and the range. Let's start with domain. Okay? So it goes as far to the left as negative 3. The problem is because it's an open circle, I can't put a bracket there. I got to put a parenthesis. Now, follow the domain. The problem is, okay, this is an open circle. Well, what's the domain value here? Well, that is 0. There is no value of x equal to 0 anywhere on this graph, so I need to exclude 0 from the domain. So I'll put a 0 with a parenthesis. The problem is I'm not done with the domain because I still have domain values over here. So after I go past 0, okay, I can continue to go on forever, and that's infinity. So I can either be in this or in this, so I need to put the union symbol or the or statement in between them. And that's my domain. Now, my range. Following the same graph, here we start here. That's the lowest range value. Well, the y value is 0 here. But again, because it's an open circle, I cannot include 0. So following the range for this range value is 5. But again, there is no other range value here that will be equal to 5. So 5 is going to be excluded here. But there are more range values here, so we need to keep going. Start again from 5, and because it goes up forever, that goes to positive infinity. So the range can be here or here. I need to put the union symbol there for that.